equations and graphing so we can kind of understand where we're at and where we're headed. So early in the year we started doing these simple equations like x plus 2 equals 8. To solve it, we just told you to think of the equal sign as a big barrier, or the Great Wall of China is the one we used, but just a barrier so that you can move from one side to the other if you use certain rules called inverse operations. And so in order to get x by itself on one side of the equal sign, I need to subtract 2 from both sides. And when I do that, this cancels off the left side, leaving me with just the x, then the equal sign, and then 8 minus 2 is 6. And in some cases, we actually asked you to graph it on a number line. So in that case, you actually had to assign a place that you called 0 and then count over to the right 1, 2, 3, 4, 5, 6, and put a nice big dot on the number line at the location of x equals 6. And then we gave you a couple of equations that were a little more complicated, like this one. And we even, used other variables for that matter. So in this case, we're going to simplify this one and solve for y. So on the left side, we have 2y plus 5 equals, and then we got to get rid of the parentheses. So 3 times y is 3y, and 3 times 1 is 3. And then we told you to move all the variables to one side and all the constants to the other side in order to solve for the variable, which in this case is y. So in this case, since I have 3y on the right side, I'm going to move 2y over to be with it. So I'll have 3y subtract 2y on the right side. And on the left side, I have 5. And I bring this 3 over to the left side, and it becomes subtract 3. So 5 minus 3 is 2, and 3y minus 2y is 1y. So in this case, y ends up being just 2. And if I wanted to graph that, and I've got a vertical number line because if you think about it, the y-axis is the vertical number line. So here's the y-axis. Let's assign this to be 0. So the y equals 2 would be about right there, right? So y equals 2 on the y number line. Then we started exposing you to the idea that we could have a coordinate system where the two number lines intersect each other at 0, 0. And in that case, if we graph the same two equations, x equals 2 and y equals 2, instead of just a dot on the number line at those locations, we actually had to draw either a horizontal line or a vertical line to include all the points on the coordinate system where x is either 2 or y is equal to 2. So it starts to take on a new look when we add a second dimension to our situation. Then we moved on to what we call linear equations, and they look like this. You have an x value, a y value, and they're either added or subtracted together, then an equal sign, and then some type of a constant. And because of the way things work, these things can be rearranged in a different configuration, and we might have to move it back to a situation that we like. And in this particular one, the graph of it looks kind of like this. It has a sloped or a slanted line. Has a couple of places where it intersects either the y-axis or the x-axis. And so that's why we call it a linear equation, because the graph of its solutions is a straight line. In fact, we notice that everywhere along this line, everywhere you find a dot, the coordinates of that dot add up to 2. See that, x plus y equals 2. So up here at the y-intercept, you have 0, 2. Right here, you have 1, 1. At the x-intercept, you have 2, 0. So if you add those two numbers together, you end up with a sum of 2. So that's kind of interesting, isn't it? And that works for every linear equation. All of the solutions along any linear equation are solutions to that equation. We also discovered that each slanted line has some distinct properties, such as its slope and its intercept, where it crosses the x and y axis. So in this case, the slope is down 2 over 2, because those are a couple of points that we know on the line. And negative 2 over 2 simplifies to be negative 1. And we could also put 1 on the bottom, but that's not necessary. And I mentioned the x-intercept and the y-intercept. The x-intercept is where the line crosses the x-axis. The y-intercept is where it crosses the y-axis. And for most of the time in this class, we're going to be talking mostly about the y-intercept. We do talk about the x-intercept a little bit, another section or two, but most of the time we're talking about the y-intercept. Okay, we also demonstrated that when a linear equation has been solved for y, like this one has, where we rearrange it and move the x term over the equal sign and put it behind the equal sign like that, then there's the number in front of x, in this case a negative 1, is the slope of the line. And at the 2 behind the x is the y-intercept. So if you notice, there's the y-intercept of 2, and the slope of this line of negative 2 over 2 equals negative 1. That is the slope of the line. So that's something to think about. We kind of demonstrated why we're solving for y and what that looks like and how it ties into what we've been doing. So for now, we're focusing on how to solve a linear equation for y, and that is when it has been written in some other form. And you've already learned how to do that a little bit. We're going to do a little bit more of that today. So good luck. Thank you.